Okay, thank you. That was a very interesting talk. We have several questions. I'll start with Lei Shu.
Hi, I don't know why I can't start my video, but anyway, I hope the author is here. Great work. So I have a particular question about the consistency guarantee about this work. How would you compare your approach with existing approach, like using key value store such as Cloudburst, and or other approach such as using transactional storage to support consistency? And I understand that Boki support a lot more than that. For example, exactly once guarantee. But I'm just wondering, the functionalities when it comes to data consistencies.
Yeah, this is a good question. Like, shared log is actually a very useful low-level building block for building high-level storages. For even building some database like data structure, it can support very strong consistency. For example, it's sequential consistent. Like the log can order all the writes, it can guarantee all operation to this data storage is sequentially consistent. It's a pretty strong. And this is one reason that people prefer using shared log for such kind of use cases.
So the difference is that Boki provide much stronger guarantees than the other works, than the previous work.
Yeah, compared to some is stronger, and compared to some other, I probably think it's comparable. Sequentially consistent, pretty strong. Is like some is eventually, some is maybe causal. Yeah.
Okay, thank you.
Okay, thank you for that question. Next, we have Maliha Masood.
Hello, this is Maliha from UIUC. I had a question about the physical log. So it says in the paper that the number of physical log is a configuration parameter. So I was wondering what factors affect this number. And another question that I had was, do you deal with shrinking the physical log? Because I mean, if you have 1.2 million transactions per or events per second, then beyond a point, you must have to deal with it, right?
Yeah. Yeah, for the number of physical logs, I mean, the problem is configured because of one physical log, they have total order. They cannot scale unlimitedly. Now we show they can scale to a very high degree, but there might be some point where it stop. And having multiple physical log can actually make the system scale to much larger space because they're independent. And another question, you mean, what's the other question for the physical log?
The other question was about shrinking the log. How do you go about doing that? Are there certain factors that you take into account?
Shrinking, you mean scale down, or you mean remove some log entries?
Remove some log entries.
Remove some log entries actually done lazily. That they have the meta log, they have the entry to say the shrink is by trim. Trim is trimmer prefix of the log. And when you have these entries in the meta log, they will do this lazily in the background to reclaim the space.
Okay, that makes sense. Thank you so much.
Thank you for the question. We also have a question from John Austerhout.
Hi, I wanted to ask you about how do you integrate the log into the serverless world? It seems to me there's a couple of challenges. So one is that these serverless functions are very short-lived. So doesn't that mean you have to go through your log recovery protocol every time a serverless function starts up in case the previous one didn't finish properly? And then second, there are zillions of these serverless functions all executing concurrently. And so it seems like at any given time, the log could appear inconsistent because there are serverless functions that haven't yet finished. So have you thought about how you would actually integrate this into the serverless world?
Yeah, it's actually very good. For the first one, I think because of the protocol, they use the redo log to handle failure by restarting and redo the log. So if actually find it fails, they have to actually reset it. It's not every time. And for log structure storage, we use the log to actually record all the writes and reconstruct the internal states by replaying the log. But to optimize the problem machine, we have a temporary storage to materialize the states, preventing the need to replay every time. And for the second question, you mean we have many concurrent functions, and seeing the logs, we have the consistency problem. yeah, for the log, for different functions accessing the same log, they ensure the sequential consistency. That means a single function, they observe the log sequentially increasing, but between different functions, they probably will say the log a little bit different at the tail. That's somehow the truth.
But coming back to my first question, I'm not sure I understood your answer in that at the least you have to check. You're right that you won't have to do actual recovery very often, but you have to check for the possibility of recovery. So it seems like there's something you have to at least check to see, did the previous function complete?
Oh.
And again, what if there's concurrent functions going on which haven't actually completed? How do you tell the difference between some other function that hasn't finished yet versus some other function that actually failed in the middle?
Oh, I see your question. This is for the workflow parts. Actually, in both cases, they can handle it correctly. Because of the log, even if there is something concurrently running, the log, common log, they actually decides what all the operations have to be done. And they can do some operation multiple times, still ensuring the thing is correct. It's a little bit abstract, but actually I know the case you're mentioning. There can be contending functions on there doing the same thing, but they are following the same trace.
Thank you. Thank you. Next, we have Shudong Sun. Shudong.
Yes. So my question is that do we need to modify the serverless function source code to use Boki? And if so, how much modification is required?
In general, do not need to modify the source function. They have a runtime API for you to use logs. So
you do not basically intercept those runtime API and do something there. Is that correct?
It's a runtime library that you can access. I mean, it's not intercept anything. The log is storage, so you have an API for storage. And if you don't use it, you don't use it.
I see. Okay. Thank you.
Okay, still have time for a question from Zewen Jin.
Oh, hello. And here's Zewen Jin from USDC. And my question is that there are many new serverless architectures and runtimes in the academic area, like Netcore and Boki. But the power of serverless only makes sense for the huge serverless platforms. And so what do you think about the fact that the current big companies like Amazon and Microsoft seem not so positive to embrace the new architectures, and they seem to be more focusing on the backend services like monitoring, storage, message queue services to make their serverless tools more interesting and more friendly to use. Yeah, what do you think about this phenomenon?
Yeah, I mean, for large companies, they maintain their service infrastructure, mostly serving a production user and for reliability. So have to focus more on backend, make it reliable by monitoring and optimization. Our research work mostly to think what's the next for this area, especially how to improve their usability. We have more and more emerging cloud applications. When I call the motivation comes from interactive microservices needing low latency, and Boki actually comes from all these consistency challenges we encountered. So although maybe in near future, the provider, they may not immediately do this, but I think for long term, we want serverless to be a real building block for more and more cloud applications.
Okay, thank you.
Let me ask for a very quick question from Sujanya Ponapalli.
Hi, thanks for the great talk. So from the application's perspective, they might formulate functions to be idempotent to tolerate faults, right? So could you elaborate a bit more when you say serverless functions are not fault tolerant? And are there certain functions which cannot be designed to be idempotent?
I mean, idempotent is for a specific type of operations in Boki flow. And in general, it's not true for everything, actually. I mean, it needs some very detailed protocol for certain types of database, right, to be idempotent. I think some example, like previously some others mentioned to me, actually is not idempotent. And yeah, for fault tolerance problem, the service function actually, the problem actually happens the field domain of your function and your storage is not in the same domain, and they can fail in different ways. And it's pretty hard to detect each other. This is the source of all this challenge.
Okay, so let me interrupt here and thank Zhipeng for a great talk and also great Q&A session. So next we have Ximing Yu, who is a software engineer at Facebook and is going to tell us about the experience in Facebook of building a system for processing streaming events at a very large scale. So let's watch the video.
All right, thank you. So we have time for some questions. There's actually already a question on Slack. So if you want to ask a question live, you can raise your hand and we can promote you to speak. Otherwise, I can read out the question on Slack. Okay, so go ahead. You can talk now. I need to promote to panelist. Okay, go ahead. Thanks, Yingho.
Hi.
Can you talk?
Yeah, sure. Yeah, I cannot turn on my video right now, so let me just ask my question. Yeah, hello, I'm Ino from NUS, and thanks for the great talk. My question is, I have a simple question. So in the middle of your presentation, you say that one of the Boki technique is to multiplex the logbooks on internal physical log with log indices for flexible log list. And it helps to achieve high density. So could you elaborate a bit for this statement and how this technique allow you to achieve the high density?
Yeah, it's a good question. Actually, the high density meaning for service environments, there might be a lot of applications that some of them usually only use very small amount of resource. Like for example, they have a logbook that's very small. Yeah, one approach is that I just do in normal way, maintaining some independent metadata for each other and have a significant metadata overheads. You can think of some design will have that. And multiplexing can observe this metadata overheads in general. And the challenge comes from like reading is more complicated. Another benefit of this multiplexing is to say, if the underlying physical log have very high throughput and low latency, they can support on different spectrum. On the one hand, they can go extreme throughput. On the other hand, they can support a huge amount of very small logbooks with efficiency.
I see. Okay, yeah. Thank you. Yeah.
All right, thanks. Other questions? So there was a question on Slack, but Kyung-Soo, I guess, do you want to speak live or should I read it out? All right, maybe I'll read it out then. So the question was, is conference registration system a good example for serverless application? Because that was actually at the beginning of the talk.
Yeah, this is an interesting question. Like this example actually come from a previous work body. They gave an example of a travel reservation for serverless workflows. This is very particular to serverless workflow, which is, for example, provided by AWS step functions. And for travel reservation, they may say, I want to book my travel and I need to book flight, book hotel, and they need to ensure they both succeed. Otherwise, I go travel, I do not have hotel, but have flight, it's wrong. And I adopted to a conference registration, probably, to better suit our thing. But in general, this comes here. Like you have a workflow of different parts, you want them to happen at least once. I mean, they both happens, but not have the state that happens in half.
Sorry, I forgot to unmute myself.
I can ask a question if no one else has one.
Yeah, go ahead.
Hi, Zhipeng. Really great. Thanks for that. So my question is, I think one of the things that happens typically in serverless infrastructures, a single function may be invoked multiple times for fault tolerance. So you might have 3 function instances that are launched from the same call. In those cases, for Boki, would you get ordering issues, or do you ensure some form of exactly one semantics on the log?
Oh, sorry. So you mean many functions operates on the same many functions on the same log, and they have ordering issues, or many functions on the same log and they have ordering issues, or
yeah, so essentially it's the same function invocation that has been invoked multiple times by some service like AWS Lambda.
Sorry, so I mean I do not actually follow. It's a little bit lag on the audio. I do not actually follow. It's a little bit lag on the audio.
Sorry about that. My question is that if you have multiple invocations of the same function, will you end up having exactly one semantics on Boki, or will you essentially have duplicates of the same request?
Yeah, the model for exactly once means you have a workflow composing multiple functions. Exactly once means for a single workflow. Functions. Exactly once means for a single workflow. And
right, but for a single function within that workflow, if that function is invoked multiple times, would that still cause exactly one semantics?
I'm not confused. What's the real thing? Maybe we can discuss later on Slack.
Ask my question on Slack and we can.
Yeah.
All right. Okay. I guess we can, if there are no questions for now, we can actually just save 2 minutes for now, and then we can come back again for the mini panel, if that's okay. All right, then. Let's move on to the next one. All right, so next up, we have a talk from Facebook, or should I say it's Meta now. Anyway, it's going to be presented by Ximing Yu, who's a software engineer. So please play the video.